Hi, my name is Liam Bermingham, an explosive engineer for EPC-UK, and today I'll be delivering to you a presentation entitled The Digital Quarry. During this presentation, I will be demonstrating to you the latest technology that we at EPC-UK are currently implementing to achieve a fully digitised drill and blast process. I will then go on to demonstrate to you the impact that this can have on the efficiency of a quarry in operation. The way quarry companies operate is now being transformed by digitalization. From autonomous surveying practices to pre-planning of drill and blast activities and to developments in business software, these enhancements in technologies are now driving increased efficiencies across the whole industry. With these improvements and implementation of technology, we now have the ability to accurately measure, record and analyze performance data in all sectors of the quarry in operation, from the drill and blast to the load and haul to crushing and screening. By being able to utilize these KPIs that we record on site, we're now able to monitor and review blast performance and its actual real effect that it has on a quarry in operation. By collecting this data accurately, the correct decisions can now be made and implemented to reach a desired goal for a particular site. Now let me summarize the latest technology and tools which we are currently implementing to fully digitalize our blasting process. We're now using drone technology with advanced photogrammetry techniques to carry out face profiling. We've developed our own in-house advanced blast design software called EPC-UK. We now carry out GPS RTK surveys in conjunction with our drone surveys to improve the accuracy. We've now developed our own application called ExpertTab, where we can digitally record all drilling information and feed directly back into EPC-UK. Once we now probe the holes, we can feed this data digitally back through into EPC-UK. And we can also use ExpertTab again, this time to measure and monitor and record the whole loading process of a blast. We're also able to remotely fire using electronic detonators blasts from a safe location outside the danger zone. And now we're also able to perform a variety of post-blast analysis using drone technology into creating 3D models of a mud pile and feeding this through fragmentation analysis tools. And all this key information can all be fed now back into our online cloud-based database called Explore, where we can look at and analyze all this data together. However, to fully quantify the impact that the blasting process has on a quarry in operation, we also need to look at this data in conjunction with key information that's currently recorded on site. A list of these sort of KPIs, which can commonly provide an indication of blast performance. Loading times at the face. Improved loading times suggest an improvement in fragmentation, for example. Fuel usage, primarily of face excavators or front end loaders, depending on what equipment is used to load the dump trucks. Throughput through the primary crusher. Also energy consumption of the primary crusher. And percentage splits of materials either scalped off at the crusher or percentage oversized in the muck pile. And all this information analysed with the drill and blast information which we monitor and record can now allow us to make the correct decisions for future blast designs. So now let me go through each of the drill and blast stage and the technologies which we currently employ. So drone technology. With drone technology and the implementation of photogrammetry techniques, we're now to use drones to perform face profiling surveys. By taking a series of overlapping high-resolution photos from known locations, we're able to stitch these photos together and creating an accurate 3D model of the area. And through GPS surveys, we are now able to georeference these models as well. The benefits of drone technology for face profiling? Well, generally, they're safer. The survey can now take place from a controlled, safe position, usually on top of a bench. There's improved accuracy. The old geological conditions can now be recorded on the face through photos, and this can be implemented and imported straight into our expertise software. We're now capable of obtaining measurements where normally they'll be obstructed by obstacles, such as toe bunds, where a laser profile may not be able to see into, so like a toe area of a face, for example. And generally, where there's multiple setups required, if you're using a laser, surveying with a drone is much faster. The resulting 3D model from the pre-profile survey using the drone can now be fed directly into our Expertise Blast Design software package. This can then be used to calculate the profiles for that particular survey. And by using the inbuilt blast design algorithms, we are now capable of automatically generating the optimized locations for each blast hole within that survey in order to achieve an optimized energy distribution throughout that blast. So now we are able to correctly position the holes exactly where we need them before even going out on the bench to mark out or to drill. This information can then be fed onto our Explore platform, and from here can be downloaded by the driller onto the ExpertTab application. So when the driller comes onto the bench in his rig, ready to drill a blast, he can then download all the hole parameters within that blast. For example, for this blast, he can load up hole 1, and it will tell him the hole azimuth needs to be 336 degrees. The hole needs to be drilled at an inclination of 14 degrees and a hole depth of 14.5 meters. Once he starts drilling this hole, hole 1, for example, it can then start to fill in digitally all the information that he encounters whilst drilling that hole. And he can replicate this for all the holes within the blast. And then once finished, can re-upload all this information onto our Explore platform. And from here, this can be then downloaded by the shot firer into Expertise for the blast design phase. This information then can be fed directly into the face profiles, and then you can charge the holes accordingly with the information provided by the driller. So now we have fully digitalized the drilling process and how we handled the drilling data. Once we've fully designed our blast, we can then re-upload that to our Explore platform again. And from here, this can then be downloaded on the day of a blast by the bulk truck operator. Again, using the ExpertTab application on a tablet. This tablet can then connect wirelessly to the bulk emulsion truck and then can actually record what's being loaded down each hole. This can then be fed back into our Explore platform once the blast has been completed. So as well as digitizing the drilling process, we have now fully digitalized the hole loading process as well. Performance monitoring of a blast. We are now able to fully utilize drone technology and to be able to monitor the performance and review the performance of a blast. We can make use of its high-resolution 4K video cameras to video the blast, which provides a great tool for reviewing the blast and its performance. However, it doesn't truly quantify the performance of a blast. We can't put a figure to how well that blast has come out. However, by using the same surveying techniques which we employ during the pre-profiling stage of the blast process, we're able to take a series of photographs and create a 3D model using a drone. And now we can then import the 3D model of the muck-pile into some fragmentation analysis software. Through here, the software can then calculate the particle distribution, size distribution present in that muck-pile, which can then generate to us a fragmentation curve for that muck-pile based on that model. And if we want to make it specific to a certain site, we can add a couple upper and lower limits for the primary crusher for that site, for example. So here, I've put a lower limit onto our fragmentation curve of 150 millimeters. So anything below 150 millimeters, I know is going to be scalped off at the primary crusher. Now I've also put in an upper limit of 750 millimeters. Anything larger than this size, I know will be too large for the crusher and will need to be put aside for pecking. So now we're able to calculate the fragmentation of that blast pile and then work out the percentage of undersize and also of oversize for that blast. So as you can see here, 98.5% of that muck pile in that present in that model passes 750 millimeters in size, which meaning 1.5% of that model is made up of oversize. And if we look at the bottom end of the scale, we can see that just over 8% of material in that model is below 150 millimeters in size, and we know that would be scalped off before the priming. So now we're able to put a figure to our blast performance. However, just in conjunction with this is no good. What we need is to be able to look at this information in conjunction with information recorded on site through various processes to be able to determine the real effect of a blast and its performance on a quarrying operation. All this information, though, can be uploaded to the Explore platform, our online centralized storage database. This then provides us the ability to analyze and interpret blast statistics, maybe for a particular blast, maybe across a number of blasts for a particular site, or even across several different sites. Provides us the ability to generate some KPIs and plot some trends for a particular site. Like here, we've plotted blast volume against blast ratio, for example. By centralizing all this data, we're now able to analyze this data as a whole and not in isolation. And this will allow for more efficient decision-making in the future by using this data correctly. As explained, we also require performance data recorded on site. This can be typically load and haul performance data and also crushing and screening data, as these two processes are the main processes that are directly affected by the drill and blast process. By measuring KPIs in the load and haul fleet, such as loading times at the face, or loading factors, or how many passes it takes for an excavator to load a dumper, these can all be true indicators of a blast performance. If telematic data capture systems aren't installed on this equipment, these may be tricky to monitor. However, we can still monitor basic KPIs, such as fuel usage, for example. By tracking the fuel usage of an excavator, we'll be able to see if blasts are becoming harder to dig, which is a reflection of blast performance. We can record hours spent pecking from a secondary machine. By tracking the hours, we'll be able to track the amount of oversize generated from the blasts. And over a longer term, we may be able to possibly track repair and maintenance costs of a load and haul fleet as well. Improvements in blasting may see reduction in R&M due to less wear on the front-end loading equipment. But in addition to the load and haul performance, we also need to look at the processing plant performance of a site as well. These are commonly recorded across sites across the country, so it shouldn't really be an issue. The main one would be monitoring the throughput through the primary crusher. Is our blast affecting the throughput by increasing throughput or detrimentally decreasing the throughput if our blasters are coming too coarse? We can also start tracking net energy consumption of the primary crusher. How hard is it working? Can we improve our fragmentation so it doesn't have to work as hard, so it uses less electricity? And also we can look at production percentage splits. Essentially the scalpings that don't manage to go through the primary crusher, they're scalped off beforehand, or percentage of oversize from a blast. By analysing all this key data and looking at this together in conjunction with our blasting data and our blast performances, data, we're now to be able to make the correct decisions and where we need to change our drill and blast process. And in addition to this, we can actually now start to quantify the potential cost of the drill and blast stage and several other areas of the quarrying operation. To illustrate how recording and analysing all this data together can actually benefit a quarrying operation and its running efficiency. In 2018, we started a new project called the Digital Quarry project at a quarry in the UK. And the aim of this project was to implement and develop technologies, which I have explained and illustrated and demonstrated to you in this presentation, to apply this to a real quarry, to an operation, so that we can actually be able to see the benefits that we can make, not just to the drill and blast process, but also to the overall quarry operation and its performance. If we look at this graph here and look at the two data sets, one in red, one in blue. In red is the data relating to the primary power consumption of the primary crusher in kilowatt hours per tonne. And the blue data set is percentage scalpings at the primary crusher. Now in 2018, this is our background data set. Okay, this is our baseline. We didn't make any changes in 2018, apart from introducing the Expertise blast design package. So any changes we make now and the improvements we see will be compared to what we were doing before using this technology in 2018. Beginning of 2019, we use a drone photogrammetry surveying, GPS surveying, smart rigs, and later in that year, made similar other changes using staggered patterns and auto whole layout generated from an Expertise software. With these changes, we were able to track and record the performance and the impact they have had. And from 2019, we have found that on average, we have reduced the energy consumption of the primary crusher by 0.13 kilowatt hours per tonne. To put that into perspective, that's approximately an annual saving of 850 megawatt hours of energy, of electricity. In addition to this, we also saw a reduction of scalpings by almost 6%. That's almost 6% of material that can be retained and processed and sold at a higher value product than what was being scalped off previously. In addition to this, if we look at the figures going through the primary crusher, we also saw from 2019 just over an 11.5% increase in product split going through the primary. So less scalpings and less oversize. We also saw at the same time a weekly increase of tonnage by almost 11%. So to summarize our findings, we was able to decrease the power consumption whilst increasing the percentage of blasted material which feeds through the primary crusher. So overall, this has been a result of improved fragmentation and compressing that fragmentation curve by achieving a higher throughput and a lower percentage of waste material. This truly shows the benefits can be had when if you accurately record, measure and analyse all data, not just drill and blast data, but load and haul, and in this case, process and plant data together. To conclude this presentation, hopefully I've now demonstrated to you it is now possible to fully digitalise the blasting process using the latest technology. And by accurately measuring and analysing blast performance using drone technology, data recorded for mobile plant telematic systems, if available, or other key load and haul KPIs, such as fuel usage, etc. And also performance data related to processing plants, so crushing data. We are now able to fully quantify blast performance and its impact on the entire quarrying operation. We can now make informed decisions on future blast designs and thereby optimising the entire rock breaking process for a quarrying operation. Thank you for listening.